we introduce 2x2, learning multitask pairwise objects assembly for generalizable robot manipulation. Assembly tasks are common in everyday life, like building furniture, fixing home appliances, or assembling electronic devices. To carry out these tasks effectively, one must understand how objects relate to each other in space. For robots to assist humans in these scenarios, they must be able to determine the full 6D pose of each object, that is, both its position and orientation. This ability is crucial for domestic robots, as it allows them to engage with and manipulate objects in their environment accurately and purposefully. Current approaches and benchmarks for tackling assembly problems usually emphasize matching local geometric features. However, this often leads to poor performance in daily assembly tasks, which demand both semantic understanding and precise spatial alignment. The limitation arises because these methods are mainly trained and evaluated on datasets like Breaking Bad and neural shape mating, which focus on large-scale geometric fragments rather than everyday semantically meaningful objects. To bridge this gap, we introduce 2x2, the first large-scale daily pairwise assembly dataset. Compared to previous datasets and benchmarks, 2x2 offers 1,034 instances across 517 pairwise object assemblies, each annotated with precise pose and symmetry information. It covers a diverse range of everyday assembly tasks that demand methods capable of aligning geometric shapes while reasoning about the functional and spatial relationships between objects. Our dataset provides diverse task coverage across categories, with each further divided into specific subcategories. Objects within each category vary in shape, size, and type. To enhance generalization, the testing set includes objects with unseen geometric shapes. This diversity ensures generalization ability and applicability in real-world scenarios and supports robust 3D matching and assembly tasks. Along with the 2x2 dataset, we also bring up a 2x2 network, which predicts the pose of each object in a step-by-step manner to assemble them to a predefined canonical space, which refers to a standard coordinate system that aligns with the principles of the human world. For instance, bottles and vases are aligned as if placed on a table. In our 2x2 network, we employ a 2-scale SE3 vector neuron dynamic graph convolutional neural network that leverages dual K nearest neighbor graphs to extract SE3 equivariant and SO3 invariant features at 2 distinct scales. This design enhances the model's ability to capture both local geometric details and global structural context. We adopt a separate training and evaluation strategy. During training, the two networks are trained independently to predict the poses of the base object, for example, the socket, and the fitting object, for example, the plug. During testing, we sequentially predict the pose of the base object followed by the fitting object, mimicking the human assembly process like we firstly put the vase on the table and then arrange flour in it. The experiment results show that our approach outperforms the baselines across 18 fine-grained assembly tasks, with an average improvement of 0.46 in translation RMSE and 8.97 in rotation RMSE. We also highlight bottle, plug, bread, letter, children toy, key, and flower tasks to demonstrate our improved translation and rotation predictions compared to baseline methods. Additionally, robot experiments further validate the reliability and generalization ability of our method for complex 3D assembly tasks. Thank you for your listening. For more detailed information, please visit our website.